Okay, maybe we start for today. So this week we will continue with the kind of typical GIS operations that are typical in different kind of analysis pipelines. So one of the things that we will learn is how to classify data based on some kind of predefined classifiers. And the other thing what we will do is to basically learn different kind of geometric operations, such as how to conduct overlay analysis, how to do dissolve, so use specific keys in the attribute table to actually merge geometries together. And the last thing is to basically understand how we can simplify geometries based on some kind of parameter that you specify. So the data reclassification is indeed one of these kind of topics that you quite often need to do. And the idea here is that you basically want to manipulate your data in a way that you, for example, you might have some criteria for yourself, and based on those criteria, like this conditional statement, for example, here we have an example, what we will do later today. So we have two criteria. So the idea here is to have a kind of practical example of kind of doing analysis of to try to find locations where to buy an apartment. So the idea here is that we kind of make a couple of assumptions about where that kind of suitable apartment is. The one assumption is or criteria for kind of suitability of that location is that we want the travel time to a work location be less than 30 minutes from the apartment that would be suitable. And the second criteria is that for example here, well, this is not what we use, but the rent of the apartment should be less than 1,000 euros per month. But basically the second criteria here that we are really going to use is to basically the distance from the city center, because typically if we think about, for example, Helsinki, so the further away from central railway station you are, the cheaper the prices get. Of course, that's not a kind of really rule that applies everywhere in Helsinki region, but that's anyway a good indicator of the prices in the region. So using these kind of two different criteria, for example, you might create a classification that is it suitable or is it not. So do this kind of Boolean classification so that you might put a value to the row as 0 or 1 if it matches these criteria or not. But before we do this kind of practical example, we will actually take a look how we can classify data based on these common classifiers. So we will use a module called PyCell. There is a link in here to the library. So this is a kind of a spatial analysis library that has an extensive amount of different functionalities. We will not go through all of them, but we will basically just see how we can do this, use these kind of common classifiers such as Fisher-Jenks, equal interval, Jenks-Caspel, and maximum breaks, natural breaks, and these kind of classifiers. Are these familiar to you, these classifiers? These are most typically if you have done some visualizations, for example in Quantum GIS or ArcGIS. So for determining the kind of value breaks and the classes for the classification when you do some kind of choropleth map, for example. So quite often you use something like this to determine where the classes are. So, but we will see soon how they work in here. Yeah, but let's start actually going through the material. So I have launched the student binder already, so hopefully I should have it in here. Yes, so I can kind of start going through the data. There should be, so there is a download link in here, so download the data package. So if you work on your own computer, you can download the package and extract that to the location where the lesson 4 materials are. If you're working on Binder or CSC notebook, so the data should be there already, so you don't necessarily need to download anything. Yeah, but let's start by seeing how we can indeed use this PySal module to classify our data based on one of these ready-made common classifiers. So the first thing that we will do, well, first of all, the data that we will be using is this kind of travel time matrix to Helsinki railway station. So the data basically, it should be in here. It's actually a shape file. Yes. No, it's a GeoJSON, so we will use that. So first of all, what we will do is that we will import GeoPandas again. So import GeoPandas as GVD. Then we will specify the file path to the file that we want to read in. So the file is located in this data folder. So data slash, and then we have in here this travel time to blah 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 GeoJSON. So this file is what we want to read in. If I want to copy paste this, okay, I think I can also copy this path. Let's see. Okay, yeah, well, that works as well. So you can do it like that, but modify the file path in a way that we have this data slash travel times to 5975375 railway station Helsinki.geojson. So now when we have that, we can actually read the data. So I will create a variable called ACC, which is basically a short name for accessibility, and we will read that in by using gbd.read file and fp. And let's see what kind of data do we have. See the first rows of the data. So we can say acc.head, and let's say take two rows from here. And when I execute this, let's see if everything, no kernel. Okay, let's set up a kernel. So when I now execute this, hopefully things should be working. Yes, there is indeed this kind of a warning about NumPy, but you can ignore that. It's nothing dangerous. But now we have the two first rows of the data in here, and we have a lot of different variables in this data. So first of all, we have these car MD, car MT. So what these are, they are basically travel times or distances. So this first part of the variable name specifies that the, oops, a little bit too large. So this basically says that, okay, this is a travel time based on car during mid-time congestion levels, and the D stands for distance. So this is the distance based on the route that the car has taken, or where the most optimal route the car MT is the travel time basically. So we can see that, for example, on this is basically from one location to another. So these are these kind of origin destination matrix what we have in here, and the travel time has been 41 minutes. And then we have the same thing for rush hour. So R stands for rush hour and so on. Then we have public transportation, midday, distance and time. We can see here the same thing for rush hour, distance and time. So the rush hour travel times have been calculated during, is it 8 in the morning if I remember right, and the middays at 12 o'clock. And then we have the same thing for walking and then some other variables here. But this is basically what the data looks like and what that is about. So the first thing maybe to understand, let's see if we have any -1 value. But well, there is not any visible no data value here, but something that we should understand is that the no data value present in the data, so there might be no data values, they have been indicated with value -1. So really the first thing what we need to do is that we need to handle the data in a way that we remove those no data values from the actual data set that we are going to analyze. And for that, I guess you have been practicing already quite a bit for doing a selection based on some criteria. So we can use the lock functionality that we have seen at least a couple of times before and do the selection based on that. So let's basically include data that is equal or above 0. And we can basically modify the data frame that we have. So this ACC equals to ACC dot lock, which is the functionality that can be used to do selections based on some criteria. And what is our criteria in this case is that we want to have that the public transportation rush hour travel time, so TT, is equal or larger than 0. So this is the kind of thing that we need to do to get rid of those -1 values. So in this case, we are interested in kind of calculating and doing analysis using this public transport rush hour travel time. So we get rid of those values. Actually, I changed this now to the name, not ACC, but let's see, public transport PTR, so that we don't get rid of the original data at this point. So let's see if we do this, and then we can plot the values to see actually what do we have. What do we have in here? So let's use this magic command, matplotlib inline. Is this more or less, do you understand this matplotlib inline, what it does? It's this kind of command that whenever we are doing plots, it will basically say to this notebook that we are writing in that everything that is plotted inside these cells in here kind of plot the figure underneath the command, the plot command. So that's kind of just a trick that we need to do. If we wouldn't use this, well, we can see we have just a problem that it doesn't show anything. So let's make an example so you will understand why this is done. So let's first import the matplotlib.pyplot. So this is again the package for doing the plotting. actually we doesn't necessarily even need that. So let's plot the travel times based on Fisher-Jenks classification. So we can use this data from this PTR geodata frame that we cleaned in here. So let's say PTR dot plot. And now we can use the GeoPandas plotting functionality, so we can specify what is the column that we want to plot, so where do those values come from. So we can specify with parameter column equals to, and then the column name that we are interested in, which is this PTRTT. So PTRTT is the column. And then there is this parameter called scheme. So there are a few of the different ready-made classification methods available directly by GeoPandas. And we can specify that scheme equals to Fisher-Jenks, like this. So this Fisher-Jenks classification method exists by default under the hood in GeoPandas. One of the things that we, of course, always want to determine is that how many classes do we want to use. So kind of, well, we can specify that the K, which is the parameter for number of classes, we can specify it to be that, okay, classify the values for the map in 9 different classes. It could be, well, we can put, for example, 12 classes. So let's put K equals to 12. It can be anything, you can decide. The color map that we're going to use, so with this C map, that stands for color map, we can specify what kind of color scheme do we want to use. So again, if we Google matplotlib C map, we can actually get this color map reference.py, and here we have different kind of possibilities that we can use for color maps. And what we are going to use is this, was it this red, yellow, blue? So this kind of color map, if I remember right. So we specify red, yellow, so capital RD, capital YL, capital B and U. So this is red, yellow, blue color map. Then we can specify that the line width, so basically because we have those polygon grid cells, so we can specify that the line width for all of those polygon boundaries should be 0, so we don't want to have any color on those, so we can specify line width equals to 0, and then we can say that legend equals to true. So show legend whenever doing this plot. So these kind of parameters we can use. And now let's okay. Well, now it does. Yes, here it is. Yeah, this is quite slow on computer when running these things. This is much faster. I don't know what was the reason for taking so long. But anyway, so now what we have in here is that we indeed have classified. Well, now I have 3 classes because I set it to be quite small, so that we have these had the map values in here. Actually, now now it seems to be showing the figure as well.
It seems that once you run matplotlib
PLT,
even after you go back and delete it, it remembers
yeah,
that you ran it.
Yeah, might be, yeah. Well, but the purpose, what I expected to happen without this matplotlib inline was that it would have given me this, but not the figure. That is behavior that sometimes happens. But well, now we have a map, and that's the important thing. But that's the, if you don't see anything coming with these plot functions, so you might need to use this magic function matplotlib inline. So that's the purpose of it. But as we can see, now we have basically classified the values into 3 classes. So now we have the first class goes from 0 minutes to up to 37 minutes. The second class goes from 37 minutes up to 62. And the third class goes from 62 up to 155. So we have actually fairly large class breaks, or kind of they are far from each other in this case. So this red is basically now showing the 37-minute area from railway station using these different colors. So this Fisher-Jenks and how these classifications have been done. So it's based on this Fisher-Jenks classification method, which is a statistical way of determining classes from the data values. There is a lot of materials and documentation, so there's a link in here that hopefully goes to correct places. So here you have, this is now from the PySol documentation, where you can actually see better documentation for each of these different classification methods. So what we now used was this Fisher-Jenks that is basically included in the in GeoPandas. Good, but that was the first kind of classification thing. Let's create another plot using the walking distances. So now what we want to do is that we use, so plot walking distances. So this relates to the original question. So basically, if the travel time to work is less than 30 minutes and the distance, walking distance from city center is above some criteria. So let's take a look using the walking distance as kind of the Euclidean distance from the city center as a second parameter. So let's plot the walking distances. So the first thing what I want to do is that I use this acc.log to actually remove all the values with no data. So I say that walk equals to acc.log, and inside we say that acc walk distance, so walk d is larger or equal to 0, and those values will be stored into this walk parameter. So then we can just plot walk.plot, and the column that we want to use is again this walk d, and let's use the same scheme. So Fisher-Jenks, I now use this k equals to 3 and use the same color map as before. So color map is red, yellow, blue, BU. Line width equals to 0, and the legend should be on, so legend equals to true. So let's see how this looks. Is this as slow with your instances?
Yeah.
Okay. It seems to be really slow instance that we have from the, it might be that actually the CSC ones, they have probably much faster instances there. Okay, but now what we have is that we have indeed those walking distances classified into 3 classes. So the first class goes from 0 up to 8 kilometers. So we can see from the railway station kind of distance. Well, it looks like a buffer basically, because they are network distances, but walking the shortest distance. And then we have the second class and the third class. Good, but as there might be quite often cases where this Fisher-Jenks and couple of other classifiers such as equal intervals and quantiles. So those 3, if I remember right, comes with GeoPandas package directly. But there might be cases where these are not suitable for you. So you might, for example, want to use these natural breaks that is fairly commonly used, or a standard mean or percentiles, or well, any of these others, or you might have your own user-defined classification method. So let's see how we can actually use those ones. And basically now we will go back to using the apply function, and we will basically first define the classifier that we will be using. So what we will first do is that we will classify the values based on natural breaks. And after that, I will show you how we can classify the values based on your user, basically your own defined classes. So we can, for example, now we have the travel times in here. So we can say that the first class should be from 0 minutes up to 10 minutes, 10 minutes to 20, 20 to 30, and so on. So this kind of thing. So for this, we are going to use the PyCell package. So we want to import PyCell as PS, and let's see that that works. For me, at least it does. There might, let's see if I had some warning somewhere. But if you see a warning, kind of deprecation warning about when you import this, it might probably say something like there is a new API coming. So indeed this PyCell package, they have renewed the whole code base, and they will kind of, well, it will start working a bit differently next year. But anyway, I assume that most of the things work more or less in a similar manner. But let's define first the number of classes that we want to use. So we can say that k equals to, let's use now 9. Let's see if this goes a bit faster like this. And then what we want to do is that we want to kind of initialize the classifier, the natural breaks classifier. And we can create and do that by creating a variable called classifier. And how do we create this is that we use this PS package, and here we have a list of different, this is for example boxplot classifier, but we should have a natural breaks classifier here. So specifying PS dot capital natural underscore breaks is basically the natural breaks pre-existing and the common classifier that we can use. And we initialize that by using a kind of function called make from this natural breaks classifier. And we say that make, and this is a function, so it takes as a parameter the number of classes that we want to use. And it has a parameter called k equals to, and then it wants to have the number of classes that we have. So, well, we have the number of classes defined in this k variable here, so we say k equals k. So now we initialize this classifier with 9 classes. And executing this, does not yet do anything. But now what we want to do is that we basically want to use this classifier and apply that to the column of interest that we have. So now we have the method for ourselves, but we want to run this method with the column of values that we have. And we want to classify now these public transportation rush time, travel times. So let's see how we can do that. So we can say that classify the data. So we will create a new variable called classifications. So this is the place where we will store those classification values. And basically how this can be used is that we run this for the earlier here. So this is the data frame for the public transportation rush hour travel time. So we have this PTR that we did here, the first step that we did. So we use the data from that geodata frame, so PTR, and then we basically want to specify that to which columns do we want to use this classification. So how can we do that is that we basically specify inside square brackets a list of those values that should be classified by this method. So now we have basically these outer square brackets just stand for that select certain columns from this geodata frame. So here we select that, okay, PTR TT is the one that we are interested in. And this could be, you could at the same time basically do classification for multiple different columns and it would run it at once. So we could basically set up a list of values in here, such as car, RT, and so on. But now we are only interested in this one value or one column in here. And then this is basically selecting that column from the geodata frame, and then we want to apply. So for all of these values that exist in this column, we want to use this natural breaks classifier. And how we use this apply function in this case is that we just say that apply, and inside these parentheses we specify the classifier that we want to use. And in our case, it's basically this classifier that we had here. If we take a look at the type of this classifier, we can see that it's a function. So actually, and as we have seen before when using these apply functions in GeoPandas or Pandas, is that it wants to apply some function to the data. So the function that we have is the classifier in here. We will later see a bit more explanation about the apply function when we are creating our own custom classifier. So let's leave this now in like this. I will explain a bit more later. And when we have done this, let's just plot, not plot, but show the first rows. So when we have, so what it will return is a data frame, basically. But let's now run this. Let's see how long does it take now. Hopefully not too long. Well, not that long. So this was actually quite much faster than this Fisher-Jenks classifier. So now what we have as a result is that it basically classified all our values. Let's take a bit more, 50, and I'll comment that out. So now this is now the 50 first rows of the classification that we did. And what we can see here is that, well, we have the index values in here, then we have the column name that we did for or used as an input data, and it is actually the same name as the original data. So as we saw from here, we pass this data from this PTRTT column into this classifier, and as a result we get all the rows from the geodata frame in here, from this PTR, and to which class that the value on that one belongs to. So we can say that see that the first 11, well, the first 12 rows, so up to index 11, belongs to the class number 8, and then these values seem to belong to class number 5, and so on. But as you can see, this is not yet that useful, because this is now separate from the original data. So what we want to do next is that we want to take these classifications and basically create a table join so that we get them back to the original data that we have. But before we do that, we actually want to rename this column in this classification data frame that we have, because if we would now just join it, it will basically try to override the original values. So let's rename the value in a way that it basically also gives information about what classification method was used. So we will basically rename the column as MB underscore PTRTT. So it's good to have, for example, in here, so we pass this NB to say that, okay, this was natural breaks classification that we did in here. So what we can do is that we can just pass in the classifications equals to classifications dot rename. This is something that we have seen before. We can use the columns parameter, and we can say that rename this is the old name, so PTRTT, and the new name should be MB underscore PTRTT. And let's see if we take head from that one. And what is the set object? Is not. Oops. This should be like this. Yes. So yeah, there was a comma instead of colon, so it should be colon. So now we can see that the column name was changed to NBPTRTT. Good. So now we want to join the classifications with the or to original data. And how we can do that is that we can use this PTR equals to PTR. We can use this join function to join the data frames together based on the index value. So we just say that ptr.join, and what do we want to join here is this classifications. And now if we take ptr.head, now we should have a new column in the end in here called pt and bptrtt. And now we can see that this is the last class, so most probably the values, the travel time values in PT, the original one in here, are fairly large as they are. So this is 77 minutes, 75, 130, 132, and so on. So now we have the classification done. So as we can see now, it's basically written as a separate column to the original data. And now what we can do is that we can actually use that column to do the plotting. So let's plot the classified values. So we can say that ptr dot plot, and now the column that we want to use for plotting is this new mb ptrtt. And we can say that line width equals to 0 and legend equals to true. So now we don't need to, let's also specify the color map to be this red, yellow, blue. So now we don't need to specify the scheme or the K parameters because we use basically our own classification that we did earlier. And now what we can see, actually, yeah, we have the legend in there. Now what we can see that we have much kind of, well, we have 8 classes in here, and we can start seeing some kind of patterns from the data. So from here, for example, we can see there is the metro line going, so we can actually see how the travel times close to those metro stations to railway station are shorter than, for example, in some outer skirt areas. So this is how we can use the custom classifier, or these ready-made classifiers from this Paisel package. What I will do now, this is not actually part of the materials on the lesson, but I will show you how we can use these user-defined classification. So we can basically specify indeed the class breaks to be 10, 20, 30, 40 minutes, for example. So let's do that. So use user-defined classification method with own class breaks. So first of all, what we need to define is to define a list of class breaks. So define those points in the data where we want to specify that everything, for example, let's say class bins equals to everything from 0 up to 10 minutes should be one class. So this is the first class break. So it basically says that everything below this point should be one class, everything up above 10 minutes should be another class. So basically specifying this one number in here divides the data into 2 different classes. But of course we want to use, for example, 10 minutes, 20 minutes, 30 minutes, 40 minutes, 50 minutes, 60 minutes, 70, 80, and 90. So with these numbers, we can basically create this kind of continuous, well, not continuous, but these class breaks with equal 10 minutes kind of classes. And how do we use these? Is that now we need to initialize user-defined classifier. So in a similar manner as previously, when using this, where is it now? In here, no, this is where we used it. But in here, in a similar manner where we initialize the classifier to be natural breaks. So now what we can do is that we actually use, so we create a classifier, but from this PS, so this Paisel package, we use capital user_defined. And in a similar manner, we call user-defined dot make. And this, again, it kind of initializes the classifier. And now as inputs in here, we actually, let's see if we can get documentation. So now what we want to specify here is this bins parameter. So we specify basically that take those class bins as an input, and this is now kind of initializing the classifier. Let's see if that works. Yes, it works, no errors anywhere. So now we can basically use the self-made classifier, and we can again create, let's say, classes equals to, and let's use the PTR data again. So this is the data frame for the public transportation rush hour travel times, and from there we want to classify the PTR TT values. So do in a similar manner as before, and then say that dot apply. And now what we want to apply, well, it's this classifier that we defined earlier. So classifier, and like this. And this is how we can use our own class breaks in the classifications. And now let's take classes.head to see that it works. So yeah, now we seem to have 10 different classes. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And as you remember that there is always the kind of one extra class in here. So we have those in the data as well. So now what we want to do is that we want to rename. So rename the column. So we can say that classes, actually this is a different way of defining the column names. So we can say that classes.columns, and in here we can basically specify all the column names for our geodata frame at once, and because we only have one column in here, we just pass one value inside this list. So we can say that user-defined PTRTT. And if I do this, okay, well, it seemed to work. So let's see if I have classes dot head. Yes, so yeah, now we're back on game. So now what we did was that we renamed the column to be UD_PTRTT, as we can see. So now we want to join to the original data, join classification to original data. So we say PTR equals to PTR.join, and now we join the classes in here. And that's done. So the next thing is that we want to make a plot. So make a plot with user-defined classes.
Just a question.
Yeah.
When you use the classes columns, how did it know which column?
Basically, yeah, that's a good question. So typically, if you want to rename columns and you have a large set of columns, let's say that you have 20 different variables, so you don't never want to do this, but you want to use the dot rename as we specified in here, where you specify the old name and the new name. But because in some cases it's just a quicker way of doing things, because we only have one column in the geodata frame, so we can just basically kind of say that the columns in that classes data frame in here, we just give it a new kind of list of column names. But if you would have, if this classes geodata frame or the data frame in here would, for example, have 20 different attributes, so you should provide a list of all the column names basically in there, and basically these should be in the same order as you would have those attributes. So this is good if you only have like 1 or 2 columns, so it's faster to write than using the rename functionality. But that's how this works. Good, yeah. So, but yeah, let's make a plot. So let's use this ptr.plot, and then the column that we want to use for doing the plotting is now this user defined. So ud_ptr_tt, and we can use the color map red, yellow, blue, and legend equals to true, and the line width equals to 0. So let's see, what do we have now? So now we have this kind of map, which starts to be already much more informative in a way that now we can basically say, because we defined our own classes in here. So there is a class break every 10 minutes. So now from the map we can see that, for example, this red area here is basically the 10 minutes travel time zone to railway station. The next level is basically the 20-minute zone, and the next one 30 minutes, and so on. So this is kind of a really good way of using this kind of self-made classes. I use this user-defined classifier quite often when doing different kind of choropleth maps such as this. You might have, for example, population densities, and then you want to say that, okay, 500 persons, 1,000, 1,500, and so on. So it's quite useful function to know. Good. Do you have any questions at this point? So this is the same idea how these classes from Python can be used. So the kind of process and the steps that you need to do is really similar for all of those different classifiers that we want to use. Yeah, but do you have any questions, or do we move forward? So I think this is, especially when creating maps such as these, using these classifiers is highly useful when having some numeric data that you want to define as classes. One thing, it's possible to change, of course now we have the class numbers in here, so it is possible to give the original, let's say that x equals to ptr.plot. So it is possible to basically get the legend labels from this x axis. So if you create the plot using this x equals to ptr.plot, so everything related to this axis is basically stored inside this x variable in here. And from here we basically, let's see if I remember it correctly. Is it? Stick labels. Yeah, well, I don't remember now from my heart. How did you actually, what was the correct attribute to get those values, but I will figure that out later. But basically the idea is that you can get access to these values so that you will have those 9 or 10 different classes, and then you can update those values to this plot. So then you would have basically here like the value in here would be 10, 20, 30, 40, 50, 60, 70, and so on. So that's kind of how you can update these class numbers to be more more sensitive. The other way, of course, is that you can basically kind of relabel the actual values in this UD, PT, RTT column. So, well, let's do that so you can see. So, multiply by 10. So, this is not maybe the perfect way of doing, but just to quickly demonstrate what we can do in here. So we can say that this PT, UD, PT, RTT column will be multiplied by 10. So then we should have, what does it complain? Columns overlap, but no suffix. Well, let's create a new one. Minutes. Huh? What is happening? PTR user-defined PTRTT dot head. Yes. Why cannot I multiply that by 10? Here again, is there something? Oh yeah, it's actually, yeah, okay. It was complaining about this join, not actually this part. Cool, but now what we did was that we multiplied basically those values with 10, and now what we have in here, I just changed this to the new column, and now what we have is that we actually have 10 minutes, 20 minutes, 30 minutes, and so on. This was now a special case because we have those classes specified in a way that they were like 10 minutes classes, so it's easy to just multiply the class values so that we can actually get these in here. But in other cases, and much more secure way of doing is that you just update these values from the axis, actually. Good, but as a last thing before having a coffee break, what we want to do is that we want to create a custom classifier. So indeed the idea now is to find suitable locations to find a good apartment to rent or buy. So what we will do is that we will now create a self-made function that takes basically various parameters in here, and then we make two conditions so that basically if the travel time is less than something but the distance is higher than something, basically give the criteria or give the result 1. If not those criteria matches, give result as 0. So what we will do is that we will basically create this classifier. So let's create a classifier called custom classifier. So custom classifier is the name of the function. Is at this point now I guess you have already a few times needed to do functions. So is how do you create a class a function? Is it more or less you know how to do that? A functioning. So you use this definition, then the name of the classifier, and then you specify some parameters for that, such as this classifier takes one row from the geodata frame as an input. So we have a parameter called row. Then we can, for example, have two different, because now we want to use input information from two different columns. So one column has information about the public transport travel times, and the second column that we want to use is the walking distance from city center. So what we want to use is that we want to say that what is the column number 1 and what is the column number 2. So we specify these kind of parameters. So these will just contain information about the name of the column. Then we want to have this function as generic as possible. So we want to say that the threshold for this first column and the threshold for this second column should be specified with these parameters. And then we want to specify the output column in here. You will soon understand better what do we want to do in here. But basically the idea is that if this column 1 would be the travel time with some travel mode such as public transport, so we want to create a criteria that if the travel time is less than threshold 1. If the travel time in column 1 is less than threshold 1, then do something. So we can create if the value in one specific row, so if row and the column 1, so now what this takes is that it will use the column that has been specified in here is less than the threshold specified in here. So if the row on column 1 is less than row threshold 1. So now we have one criteria, and now we can basically do something. But we want to have a second criteria as well. So we can say that if the travel time in column 1 is less than threshold 1, and the distance in column 2 is larger than threshold 2. So we want to do this kind of criteria in here. Let's see if computer does work again. So we can specify that row on column 2 is larger than okay, actually not this. This is like this. Is larger than threshold 2. So these should be just numbers that we specify, and these are actually checked from the row. So I had a mistake in previously to specify row threshold 1. But now we can use these two different thresholds. Yep. But yeah, so let's continue. So if these criteria is met, let's specify that the value in the output column that we have specified should be 1. In other cases, the value in the output column should be 0. And then what we want to do is that we want to return that row back to us. So this is now basically a self-made, this kind of classifier that we have done. Let's see if we can execute that thing. Yeah, now that works. And this, yes, now we're back in game. So now we have this self-made function, and let's see how we can use that to find suitable areas for buying an apartment. So let's first of all create a column for the classification. So we can, with this ACC data, so the original data, we can create, well, let's use actually the PTR data frame. So PTR suitable area equals to none. So we will store the values in this column, and we will use the function to do that. So we can update this PTR geodata frame that we have by saying that ptr.apply. And now we are back in this apply function business. So the first thing that this apply function does is that it will basically apply any function and run that function through the whole geodata frame. So we need to specify what is the function that we want to use. So that's always the first parameter. So we say that use this custom classifier that we did in here to classify the values. And then we need to kind of update these parameters in here. So the column 1 that we want to use in here, well, those are, as we can see, if the travel time in column 1 is less than the threshold 1. So we can say that if the travel time from PTR TT is less than threshold 1. So we can say that the threshold 1 equals to, well, let's say 30 minutes, and that's our threshold. And then the second criteria, and the distance in column 2 is larger. So the column 2 should be distance information, and we can basically specify that, okay, let's use the walking distance. So walk D is larger than or smaller than, no, larger than threshold 4 kilometers. So the location should be more than 4 kilometers from the city center. And then the last thing that we need to do is that we need to specify what is the axis direction equals to 1. So now we have specified the function that we want to use and the parameters in here. And the last thing we want to specify that go row by row instead of column by column. So axis equals to 1 is doing that. And after this, let's see PTR, the head. So PTR.head. And what do we have in here? Threshold 2 should be this one. Let's try it again, and another error. Output column, yes, that is true. So we forgot one parameter, which is the output. Output column, so output col equals to this suitable area. As you can see, looking at the error message in the end is a good location to look for what is wrong with the code. And now we finally managed to run it. And now what we should have is that we should have a new column in our data frame called suitable area, which has zeros, but hopefully there should be some number ones as well that basically meets the criteria of these two criteria that we had. Let's see. Let's basically take like how many suitable grid cells were there. So we can use this PTR and then the suitable area dot value counts. This is a useful function to basically calculate that how many such areas or such grid cells there were that meets the criteria, and we seem to have 351 such areas. So let's see where they are located. So let's plot those. So we can see that plot PRT dot plot, and the column that we want to plot is this suitable area, and let's say line width equals to 0, and let's see, name PRT PTR, and okay, now we seem to have these kind of locations that meet our criteria. So they are at least 4 kilometers away from city center, seems to be more or less correct. But still, from these locations, the travel time with public transport to the city center should be less than 30 minutes. And now basically we can really easily modify this by just passing different parameters in here. We can, for example, say that the travel distance to city center should be only 20 minutes, so faster. So I just modified this parameter here and recalculate it, and let's see what do we have now. Well, now we have only 9 such locations that meet the criteria, and we can see where they are just by plotting. So now we can see that we have a few locations in the eastern Helsinki that actually are really fast. From there, it's really fast to reach the city railway station, so close to these metro stations. So this is Herttoniemi. This is most probably Siitie metro station, and so on. But indeed, so basically just modifying the input parameters for the classifier, it's really easy to play around with different criterias. And this is how we can basically do some own self-made classifiers based on multiple different criterias. And in a similar manner, depending on what kind of research problem you might have, of course, kind of using similar approach is highly usable for any different kind of data that you might have at your hand. Yeah, but any questions? Yes.
So in your work, do you ever actually use the axis equals 0?
Yeah. So you're talking about this. Yeah. So this is basically when we are using the apply functions such as like this. So you always need to specify, because now we are basically using this apply, and it basically runs through the whole geodata frame. And in this geodata frame, it's kind of it's two-dimensional space. So you have rows and then you have columns. And because we have this apply function is a really generic function. So it basically can do things so that it will go column by column doing things. So you might, for example, I don't know, if you have data in a way that you have, for example, some numbers, and you would like to do some moving window things that you, for example, on the 4th column, you basically take the sum of the 3 last ones and then you move. So that's, for example, something that you might want to do. And if you want to go column by column, then you would use axis equals to 0, but in here we want to go row by row, so we specify axis equals to 1. So that's the reason for that. Good. Any other questions at this point? If not, we could take a, let's say, 10 minutes break. So let's come back by 10 to 2 and continue on the next topic.